In example 10, we are given several interest rates and a variety of compounding periods. And we want to know for each of these interest rates, what is the APY, what is the annual percentage yield, or this is also called the annual effective interest rate. So the formula for APY is listed in the notes as well as the textbook. It's this. APY is equal to 1 plus I to the m minus 1. Effectively, what you're doing here is you are looking at what happens if you invest $1 and allow that to accumulate interest over the course of 1 year, and then you see how much interest that you've calculated, and that turns out to be your interest rate, your effective interest rate. So let's see how this works in action. In Part A, we have an annual rate of 6.8%, and we are compounding annually. Okay, well, it's not too hard of a stretch to understand that if you are compounding annually, then that nominal annual rate that is given is actually going to be the effective rate, or the APY. But let's plug into the formula just to confirm. So I, in this case, is R divided by 1, so I get 0.068. So my APY here is going to be 1 plus I, so it's 1.068 raised to the m minus 1. Okay, and if I go through and calculate that, I certainly just get 0.68 back out, 0.068. So it comes as no surprise, the annual rate here, or the APY for this annual compounding rate of 6.8% is, again, just 6.8. Okay, so let's look at a more interesting example. In Part B, the rate we're using is 6.75%. But we're compounding semi-annually. Okay, so I need to find out what my semi-annual rate is. So I take 0.0675 and divide by 2, and that's going to give me 0.03375. And my APY then is 1.3375 raised to m minus 1. And if you go through and calculate that, you get 0.0686, or as a percent, rounded to 2 decimal places, I get 6.86%. That is the APY here. So notice that even though the nominal rate is a little bit higher in Part A than it is in Part B, because of the difference in compounding frequency, I actually get a slightly better APY, or effective interest rate, for Part B than I do in Part A. Okay, so now let's move on to Parts C and D. In Part C, I have an annual rate of 0.0676, and I am compounding 4 times a year, quarterly. So I need to calculate my my quarterly rate, and that turns out to be 0.0169. So my APY is going to be 1.0169 raised to 4 minus 1. I plug that into my calculator, and I get 0.0693. So my APY in this case, or my effective, in other words, my effective annual rate of interest, is 6.93%. Okay, now one more example. part D. I have a rate of 6.7%, but I'm compounding monthly. So I need to calculate my monthly rate. 0.067 divided by 12. I get this sort of ugly repeating decimal. 0.005583333. So my APY is 1.005583333 raised to 12 minus 1. And plugging all of this into my calculator, I get 0.0691, or in other words, 6.91%. So of all of these, it looks like the one that gives me the best effective rate is C. Here I have an effective rate of 6.93%. So this one is slightly better than the others.